The final problem in section B of the student packet has to do with superposition of gravitational forces. So in problem 6, we see a diagram that shows 3 masses. And let's just assume that these are far out in space, so there's nothing else. There are no planets or anything else close to them. The only forces in this situation are gravitational forces between the masses. Okay, so there's 3 of these. They've got different masses, and you can see they're arranged in this triangle. The problem is asking us to find the net gravitational force on mass A up there in that corner. So the first thing that I should do is make a force diagram to show all of the forces acting on mass A. Okay, remember that every 2 masses exert an attractive force of gravity on each other. So in other words, they try to pull each other closer together. So mass B is exerting a force of gravity on mass A, and it is trying to pull mass A toward the center of mass B. So there is a force of gravity being exerted on mass A by mass B, and it is pointing in the direction, directly down, because B is trying to pull A closer to its center. Okay? Also, mass C is exerting a force on mass A, and mass C is trying to pull A toward the center of C. And so we see a force of gravity at an angle here. This is the force of gravity on mass A that's being exerted by mass C. It would be a really nice thing to have the angles in standard position to give the directions of both of these forces. So remember that standard position, we start on the positive x-axis and we rotate counterclockwise until we hit the vector. So for the force of gravity on mass A by mass B, that angle is 270 degrees, right? It's 3/4 of the circle. Let's see, I'll use green here. The angle for the other force is bigger, right? In fact, what I'd really like to do maybe is find this angle alpha and subtract it from 360, and that would give me the direction of the force that C is exerting on A. So I think that angle alpha is right here in the diagram. And so if I could find that, then I'll know how to find the direction of the force on A by C. Well, I think this angle is equal to the arctan of the opposite side, which is 4,200 kilometers, divided by the adjacent side, which is 9,700 kilometers. Remember, I'm taking the arctan because I want to find the angle. Tangent of alpha equals 4,200 divided by 9,700. Okay, and so I get that alpha is an angle of 23.412 degrees. That must mean that the direction of FG on A by C is 360 minus that 23.412. Which is an angle of 336.6 degrees. Okay. Now that I know, I see that I have 2 forces that I have to add. I need to add these 2 vectors. Remember, you have to put vectors in rectangular notation before you can add them. So I need to find the x and y components of both of those force vectors. So I've got a table set up here to do that. So I'm going to find the magnitude, or just the amount, and then I'm going to use the angle to find the x and y components. So for the first force, which is the force that B exerts on A, my angle is 270 degrees. And for the other one, it's 336.6 degrees. I get the magnitude using the universal law of gravity, which is G, big mass, small mass, over R squared. Okay, so I have mass of A is 4.4 e to the 8th. Mass of B is 7.3 e to the 10th. And it tells me that they are 4,200 kilometers apart. Remember, I have to make that meters by multiplying by 1,000. Okay. So let's see what this is. So the force that B is exerting on A is 1.215 e to the -4th newtons. If I multiply that by the cosine of the angle, I'd get the x component. If I multiply by the sine of the angle, I get the y component. I can really tell just by looking at my figure that this point's only in the y direction. There is no x component, right? That whole thing is in the negative y direction. But if you had any doubt, just do that magnitude times sine of theta and you would get this. Okay, let's find the force that A is exerting on C. I'm sorry, that C is exerting on A. So one thing I'm thinking, I don't know yet the distance between the center of C and the center of A. I need to find the hypotenuse up here in this triangle. I can use Pythagorean's theorem to do that. So this hypotenuse should be equal to the square root of 4,200 kilometers. I'm making it in meters, plus the square of 9,700 kilometers, and then I take the square root. And so I get 10570,241 meters. That's the distance between C and A. So now I'm able to calculate this force. It'd be the universal gravitational constant times the mass of A times the mass of C divided by that distance that we just found, squared. Okay, and I get a force of 2.128 e to the -4th newtons. Now, this is at an angle of 336.6, so I'm going to have to take that magnitude times the cosine of 336.6, and that gives me the x component of 1.953 e to the negative fourth. I'm going to take that magnitude, the 2.128 e to the negative fourth, times sine of 336.6, and that gives me the y component, which is negative 8.450 e to the negative fifth. So the net force acting on A, I have to add the x components. When I add the two x components, since one of them is 0, I just get 1.953 e to the negative fourth, and then I add the y components. And so I get a negative 2.06 e to the negative fourth. Okay, that actually is the net force, but it's in rectangular notation. And this problem asked us to give the answer as a vector in polar notation. Therefore, I just need to make this into polar notation by finding the magnitude. Remember, that's the square root of the x component squared plus the y component squared. And so we get 2.838 e to the negative fourth newtons. And I also have to find the angle by taking the arctan of the y component divided by the x component. Notice that in this situation, the x component is positive and the y component is negative, and so it's in the fourth quadrant. That the net force is pointing down in the fourth quadrant, so I need to add 360 degrees to what my calculator gives me to get a fourth quadrant angle. Okay, so arctan of the negative 2.06 e to the negative fourth divided by the 1.953 e to the negative fourth. That gives me a negative 46.5, but I'm going to add 360 to it, and so we get an angle of 313.47 degrees. So just putting that all together, the net force in polar notation is 2.838 e to the negative fourth newtons at an angle of 313.47 degrees. And that is the answer.